In the present video, we will discuss the quantitative forecasting methods. First, we will discuss the time series quantitative methods. In this time series method, past data are arranged in chronological order where demand is considered as the dependent variable and time is taken as the independent variable. Based on these past records, future data is estimated. In time series methods, we have to subclassify into the four methods. First one is the past average. Second one is simple moving average. Third one is weighted moving average. And fourth one is the exponential smoothing. First, we will discuss the past average method. In the past average method, future demand is estimated by calculating the average of past demand values. So we are calculating the future demand is average of the past demand values. So this method is simple and useful when demand does not change much over the time. So in the past to average method, forecast value equal to the sum of past demand divided by number of periods. So forecast equal to the summation of capital D divided by small n, when capital D is the past to actual demand and small n equal to the number of periods. So let's consider one small example. A juice shop recorded the following monthly sales of cool drink bottles. In the January month, 100 bottles sales, and in the February month, 120 bottles sales, and March month, 110 bottles. So from the past average method, forecast demand is the average of the past demand. That is, forecast equal to the 100 plus 120 plus 110 divided by, there are the 3 months record is there, so divided by 3. So which is equal to the 110. So the estimated demand for April is 110 bottles. So advantages of this method is simple and easy to calculate, requires less data, and useful for stable demand conditions. And limitations are the ignores sudden market changes, not suitable when demand fluctuates greatly. Next, we will discuss the simple moving average method. A simple moving average is a method of computing the average of a specified number of the most recent data values in a series. So in a simple moving average, to calculate the forecasting values for a specified number of the most recent data. So it uses the past demand data to calculate an average for a fixed number of periods. As new data becomes available, the oldest data is removed and the latest data is added. So in the simple moving average method, we have to considering the most recent data only. So new data becomes available, then old data is removed and the latest data is added. Since the average moves from one period to another, it is called a moving average or rolling average method. So let's see the formula to calculate the simple moving average is Ft equal to the dt minus 1 plus dt minus 2 plus dt minus 3 plus up to the dt minus n, where Ft equal to the forecast for period t and dt minus 1 dt minus 2 up to the dt minus n is the demand values of previous n periods, and small n equal to the number of periods considered for averaging. So let's see the one example problem for a simple moving average method. forecast the production for next 2 years when the production quantity for latest 10 years is as follows. So it is given the last 10 years actual production or actual demand they given. Then you have to calculate the forecasting of production of the next 2 years. So use the simple moving average to compute the forecast. So here the given data is year wise actual production or actual demand is given. So for the 10 years production or demand data is given. So then you have to calculate the next 2 years. So 11th year and the 12th year forecast demand value you have to calculate. For this one I have to use the 3-year moving average and 5-year moving average. So we know the formula is the Ft equal to the dt minus 1 plus dt minus 2 plus dt minus 3 up to the plus dt minus n divided by n. So here we have to calculate the 11th year forecasting value by using the 3-year moving average. Then F11 will become the D11 minus 1 which is equal to the demand of the 10th year plus D11 minus 2 which is equal to the D9. So 9th year demand value plus D11 minus 3. So D8 which is the 8th year demand value. So have to consider the only 3 years data only because we have to use the 3-year moving average. So F11 equal to the D10 plus D9 plus D8 divided by 3. So we have to forecast for the 11th year. In this regard we have to use the last 3 years data. So 8th year, 9th year and the 10th year actual demand values. That is the for the 8th year. So D8 is the 275 and 9th year D9 value is the 270 and 10th year D10 value is the 271. Then F11 equal to the 275 plus 270 plus 271 divided by 3. Then F11 equal to the 816 divided by 3 which is equal to the forecasting value of the 11th year is the 272. So we calculated the 11th year forecasted value that is the 272. Next we have to determine the 12th year forecasted value also we have to determine. So then F12 equal to the D. So 12 minus 1 which is equal to the D11 and D10 and D9. So divided by 3. So number of periods are the only 3 years. So divided by 3. So for the forecast of the year 12 is we have to considering the last 3 years data that is 9th year, 10th year and 11th year we have to considering the forecast value that is the 272. So 9th year demand is the 270 and 10th year demand is the 271 and 11th year not a demand value forecasted value that is the 272. Then F12 forecasted value of the 12th year equal to the 270 plus 271 plus 272 divided by 3 which is equal to the 271. So we calculated the 11th year and the 12th year forecasted production quantity by using the 3-year moving average. So values are the F11 equal to the 272 and F12 equal to the 271. So now same procedure we have to calculate the forecasted value of the 11th year and 12th year by using the 5-year moving average. First we have to calculate the 11th year. So we have to considering the last 5 years data we have to consider. So F11 equal to the up to the 5 years. So D10, D9 and D8 and D7 and D6. Only 5 years data only you have to consider for a 5-year moving average. So have to take the average of the this last 5 years data. Then F11 equal to the 260 plus, 265 plus, 275 plus, 270 plus, 271 divided by 5, which is equal to the 268.2. So similarly you have to calculate the, so for the 12th year also. So for this one, for the 12th year you have to considering the, so last 5 years data. So F11 value is the 268.2. So you have to considering the, so last 5 years data. So 11th one, 10th one, 9th one and 8th one and the 7th one. So F12 equal to the D11 plus D10 plus D9 plus D8 plus D7. So which is equal to the 265 plus 275 plus 270 plus and 271 plus 268.2 divided by 5, which is equal to the 269.84. So this is the procedure of a calculate the forecasted value by the simple moving average method. Next we will discuss the weighted moving average. Weighted moving average is an improved form of the moving average method. In this method, different weights are assigned to past demand data. So in the simple moving average, same weight is given for the all the demand data, but in the weighted moving average, different weights are assigned to the past demand data. More importance is given to the most recent data because recent demand reflects the current market conditions better than the older data. Now question will be rise, how to assign the different weights to the past demand. And moreover, the sum of the all weights is always equal to the 1. So let's see the how to assign the weights for the past demand. Let's consider there is the small n number of periods. Then first you have to find the sum of the n periods, that is the summation of n equal to the n into n plus 1 divided by 2. And next weights will become the n divided by summation of the n, comma n minus 1 divided by summation of n, comma n minus 2 divided by summation of n up to the 1 divided by summation of the n. So let's see the one small example. Let's consider number of periods are the 4. Then summation of the this one equal to the 4 into 4 plus 1, that is the 5 divided by 2. So where the 2 will get cancelled. 2 into 5, which is equal to the 10. Then summation of the n equal to the 10. Then weights will become the, so n divided by summation of the n. So that is the 4 by 10, 0.4. And next one 3 by 10, 0.3. And next 2 by 10, 0.2 up to the 1 by 10, which is the 0.1. And summation of this all the weights 0.4 plus 0.3 plus 0.2 plus 0.1, which is equal to the 1 only. The sum of the all weights is always equal to 1. And formula for the determination of weighted moving average of the forecasted value particular period is the WMA equal to the summation of weight into demand. So then FT equal to the W1 into DT minus 1 plus W2 into DT minus 2 plus up to the WN DT minus N. Let's see the one small example for a weighted moving average method. Forecast the production for next year when the production quantity for last 10 years is as follows. So here given the last 10 years production is given, last 10 years actual demand is given. So then you have to determine the next year forecasting value, have to determine. So use the weighted moving average. So 3 years weighting moving average you have to consider to calculate the forecast. So here it is given the 10 years actual demand is given. Then you have to determine the next year. So 11th year forecast value you have to determine. For this one, I have to use the weighted moving average of 3 years time period you have to consider. So first step is we have to find the weights using sum of digits method. So we know that one the summation of n equal to the n into n plus 1 divided by 2. Here n equal to the 3 years. So n equal to the 3 only. So then summation of the n equal to the 3 into 3 plus 1 divided by 2, which is equal to the, so 2 into 3 equal to the 6. Then weights will become the 3 by 6, 2 by 6 and 1 by 6. And moreover, highest weight we have to give for the most recent year, and lowest weight you have to give the oldest year. So here it is the 3 years data have to consider 10th year and 9th year and the 8th year. Here highest weight you have to give for the most recent year, that is the 10th year. 10th year you have to give the highest weight. Next follow for the 9th year and next follow for the 8th year. Then weights will become the, for the 10th year production is 271 and weight is the 3 by 6. And next is the 9th year production is the 270 and weight is the 2 by 6. And next one is the 8th year production is the 275 and weight is the 1 by 6. So we determine the weights. So then we have to forecast for the 11th year by using the 3 years data. So then formula we know for the weighted moving average for the 11th year, that is the FT equal to the summation of weight into demand. So then 11th year F11 equal to the, so 3 by 6 into the 271. So for the 10th year weight is the 3 by 6 and demand is the 271. So 3 by 6 into 271 plus, and next year demand is the 270 and its weight is the 2 by 6. So 2 by 6 into 270 plus, and next 8th year demand is the 271 and weight is the 1 by 6. So 1 by 6 into 275, which is equal to the F11 forecasted value for the 11th year is the 271.33. Next we will discuss the exponential smoothing method. This method requires only the current demand and the current forecasted value to determine the next forecast. So in this method, to determine the next forecast value, we required the data is current demand as well as the current forecasted value. It is a modified form of the weighted moving average method in which weights are assigned to all previous data. The weights decreases exponentially with the most recent data receiving highest weight, while older data receives progressively smaller weights. So here weights decreases exponentially. So that's why we are calling this method is exponential smoothing. And moreover, most recent data we are giving the highest weightage and oldest data we are giving the smaller weightage. So then the general form of the exponential smoothing method is Ft equal to the alpha into dt minus 1 plus alpha into 1 minus alpha into dt minus 2 plus alpha into 1 minus alpha square dt minus 3 plus alpha into 1 minus alpha cube dt minus 4 up to the dash. Then we can this modified as the Ft equal to the alpha into dt minus 1 plus we have to 1 minus alpha take the outside, then 1 minus alpha into dt minus 2 plus alpha into 1 minus alpha dt minus 3 plus up to the dash. So this one we can be simplified in the form of the ft equal to the alpha into dt minus 1 plus 1 minus alpha into, so this is nothing but which is equal to the f t minus 1. So we have to give the in the simple form of the exponential smoothing formula is which is equal to the ft equal to the alpha into d t minus 1 plus 1 minus alpha into f t minus 1. So here, so for the finite number of data, alpha value should be the within the 0 to 1 only. So this is once again we have to rearrange the form is ft equal to the ft minus 1 plus alpha into dt minus 1 minus ft minus 1. And we know that one the error which is equal to the, so differences between the demand and forecasted values. So we can be written as this equation is ft equal to the ft minus 1 plus alpha into error of the t minus 1 period. And forecast horizon is the length of time in the future for which forecasting has to be done. And moreover, alpha is known as the smoothing constant or smoothing coefficient, which is related to the n period moving average, and it is given by alpha equal to the 2 divided by n plus 1, where n is the, so number of periods we have to consider. So I have to remember this formula, alpha equal to 2 by n plus 1. And the practically value of the alpha is lies in the range of the 0.1 to 0.2. And we have to remember the few points. If the forecasted value for the initial period is not given, then take the actual demand for the first period is equal to the forecast value, that is the forecasted of the first period, f1 equal to the actual demand of the first period. So f1 equal to the d1. And to take the average of actual demand data as the forecast for the first period and the proceeding further. So these 2 points I have to remember. Next we will discuss the one example problem for the exponential smoothing method. Let's see the problem. The sales of cars in a showroom in 4 consecutive months are 70, 68, 82 and 95 respectively, with alpha equal to the 0.4. Find the forecast for the next month. Here given the 4 months actual demand is given. Then we have to determine the forecast of the 5th month. So we know the formula is ft equal to the ft minus 1 plus alpha into dt minus 1 minus ft minus 1. Here time period is the 5th month. So t is the 5. Then f5 equal to the f4 plus alpha into d4 minus f4. So here alpha value we know and d4 value also we know, but we don't know the f4 value. So to determine the f4 value we require the f3. So like that, for f3 also we need the f2. So first we have to determine the all the forecasted values, that is the f1, f2, f3, f4. Then we will come to determination of the f5. So first we have to calculate the all the forecasted values. So f1, f2, f3, f4, and we know the for the first month forecast value of the first month f1 is always equal to the d1 actual demand of the first month. Then f1 equal to the d1 which is equal to the 70. So next we have to go for the f2. Then f2 equal to the f1 plus alpha into d1 minus f1. So f1 value is the 70, alpha value is the 0.4 and d1 value also 70. Then f2 equal to the 70 plus alpha is the 0.4 into 70 minus 70 which is equal to the 0. Then f2 also 70. So next we have to go for the third month f3. So f3 equal to the F2 plus alpha into D2 minus F2. So F2 value is the 70 and alpha value is the 0.4. D2 value is the 68. Then F3 equal to the 70 plus 0.4 into 68 minus 70, which is equal to the 70 minus 0.8. Then F3 equal to the 69.2. So next we will move to the F4 value, forecast of the 4th month, which is F4 equal to the F3 plus alpha into D3 minus F3. Then F3 is the 69.2 and D3 is the 82. Then F4 equal to the 69.2 plus 0.4 into 82 minus 69.2. Then F4 equal to the 74.32. So now we will move to the F5 formula. Here we know the F4 we know, alpha value we know, D4 we know, F4 we know. And substitute all the data. Then so F5 will become the F4 value is 74.32 plus alpha value is the 0.4 into, so D4 is the 95, so 95 minus F4 value is the 74.32. So if you did this calculation, we will get the forecast for the 5th month is, that is F5 equal to the nearly 83. So this is the time series methods, and thank you.